One of the things we've talked about extensively in this series is how inefficient and redundant blockchain is, and that is by design. That's what gives us immutability, and another thing it gives us is an extreme level of fault tolerance. At its heart, blockchain runs on a peer-to-peer network architecture in which every node is considered equal to every other node, and unlike traditional client-server models, every node acts as both a client and a server. And so we continue this redundancy down at the network level, where we're asking all these nodes to perform the same work as all these other nodes. Like any peer-to-peer system, we have an extremely high degree of fault tolerance. In fact, if we have 2 or more nodes online in a blockchain system, we still have a working blockchain. And when you think about that amazing fact, given the scale of major public blockchains, you can see the inbuilt fault tolerance. Let's look at Bitcoin for an example. That's a blockchain that consists of over 30,000 nodes coming to consensus on every block. And as long as we have 2 or more of those nodes online and able to communicate, we still have a working solution. That gives us a tremendous margin for error for nodes coming and going offline, for network transport issues. And it makes blockchain really a great platform to use in environments with less than ideal network or power infrastructure, because we can have nodes come offline, go back online, and when a node comes online after being offline for a while, all it has to do is sync up and get all the data that it missed while it's been offline from all of its peers. And then it's right back online, participating like all the rest. This is very different from the centralized systems that blockchain aims to replace. In a traditional client-server model, if that server is offline, those clients have no way of getting the data that they requested or performing the operations they'd like to perform. This is not the case in blockchain. And if we look back historically at other peer-to-peer solutions like BitTorrent or Napster, we've seen the tremendous difficulty that authorities have had taking some of these networks offline. And that is due to the fault tolerance you get from a peer-to-peer architecture. In fact, we saw this recently during the Arab Spring, when the Egyptian government decided one night to shut down internet access for the entire country. Well, within 24 hours, Egypt was back online and connected to the internet through a network sharing mechanism known as mesh networking, which at its heart is just a peer-to-peer method for sharing internet connectivity. So we know that peer-to-peer has a long history of providing extremely high fault tolerance and reliability, and that's why we've chosen to build a platform like blockchain on top of it. So if you're looking for a solution platform that offers you that kind of incredible fault tolerance, if you're looking to deploy a solution into areas with less than ideal infrastructure, or under conditions where nodes may come online and go offline frequently, then blockchain may be a really good platform to look at.